Hi, Dr. Mamori here. By now, I'm sure you all know my name. I've repeated this one more time also. I'm performing the experiment for you. Single and double displacement reactions. The purpose of the recording is for you to record your observation. I'm not going to write down everything for you on the chat area. I'm going to just show you what happened, explain what happened, and you are going to record the observation yourself. So be prepared when you are watching this video, so you have your data sheet already open, so you can actually record your observation while you are watching, or record it carefully so you can answer the questions. Single displacement, double displacement in general is in a displacement reaction. You are starting with a reactants and then you have your product. So a general format for single displacement is A plus B. That gives a C plus D. A is going to be element. B is going to be a solution. So is a metal ion or you have a ionic compound. And then the product, you're going to have another solution with a new metal if the reaction takes place. The reaction takes place under what condition? If the element that you're adding is more reactive than the metal ion. Metal ion has a positive charge. The element that you're adding is neutral because you take a piece of magnesium or zinc is a neutral compound. So you have this neutral magnesium, doesn't have any charges. So if magnesium, let's say, is more reactive than copper, and you have your copper in the solution, copper has a 2+ charge in the solution. So you have metal ion is called copper ion, copper 2+. That would be your metal ion. The metal that you are adding, this is just an example, is magnesium. So your magnesium is the metal, is your magnesium, and your metal ion is copper 2+. Now, if magnesium is more reactive than copper, magnesium, more reactive metal than copper, that means magnesium can give electrons. When the magnesium gives electron to copper, copper is going to take the electrons, basically be reduced, and changes to copper 0 or copper in the elemental position or neutral copper. So if copper comes out of the solution, magnesium goes into solution, there are a couple of things we have to see. We have to see like particles, like the cupric color or red particles coming out of the solution, that's copper. Magnesium should disappear, that's another evidence. Copper sulfate is blue color. Magnesium sulfate is no color, it's a colorless solution. So the color of the blue has to also be lightened. So it should get lighter and lighter as the copper is coming out of the solution. So the blue color should fade it out. It should get, if you add enough magnesium and you wait forever, of course, it's going to be colorless solution. So for me, because it's qualitative analysis, as soon as I see evidence for the reaction, I'm going to move on to the next one. So I'm not going to wait until all of the magnesium react with all the color, the full blue color is going to disappear. So make sure you are going to record your observation fast with me. On part 1, you are going to follow the procedure. Read the procedure, read the introduction part before you actually record your observation. It's like basically coming ready to the lab. You have done your pre-lab already. You know what single displacement is, what is double displacement, what are you trying to, what's the purpose of the experiment, what you're trying to do. But I start with the following procedure with just a minor explanation about the experiment, what we are doing, so you have an idea of what we are doing in case you watch the video first. So first, we are going to follow the procedure, label test tubes A to F, and we place these chemicals that is given in the procedure. For A is going to be lead nitrate. I'm going to use gloves again. I'm sorry, I don't have them. Silver nitrate specifically. Everything is going to need box of gloves as well. Okay, for the first one, A is going to be lead nitrate. So I'm going to add lead nitrate to first one. Just following the procedure, adding lead nitrate to the first test tube. Okay. And silver nitrate to B. Copper sulfate to C. Lead nitrate to D. Magnesium chloride to E. Zinc chloride to F. Zinc chloride. NaCl to G. NaCl to G. And KCl to H. KCl to H. To label. Okay. And step 2 says to get the copper, zinc, and magnesium until they are clean pieces of copper, magnesium, and zinc. To the first one, we are going to add to A and B, we are going to add piece of copper to A and B. And I'm going to polish it just to make sure that it's shiny, it's clean. Okay, A and B. To test tube C and D, going to add piece of zinc metal. So take 2 pieces of zinc, 1 for each. For C and D. For zinc is going to be C, D, and E. Also E. And we are going to add magnesium to F, G, and H. Take 3 pieces of magnesium. Going to polish them. And add to G. Sorry, F and H. What are we looking for? We are looking for evidence of a reaction, meaning that the metal is going to go in and the metal ion comes out of the solution. For single displacement, you have this table which you need to fill up. So for A, when we have like lead nitrate, the metal ion is going to be lead 2+. because it's a lead 2 nitrate. The metal that we added is copper. Copper plus the lead. If there is a reaction, if we see any reaction here, we are going to record reaction. And if there is no reaction, we record no reaction. So we have reaction or no reaction. So we're going to say no reaction. If there is there's evidence for reaction, if the color did not change, if the lead didn't come out, so we didn't see any particles of gray color of lead coming out, then there is no reaction. So we just say no reaction. For the first one, test tube A, then there is no reaction. Okay, make sure you record that. For B, okay, see what happened for B? The particles, silver particles are coming out and copper is going in. The solution changed color and we see those particles, the gray color or silver color particles coming out. So there is a reaction here. Your metal ion was silver and the metal is copper. Copper gave electrons to silver. For lead and, I'm sorry, this is zinc with copper sulfate, test tube C. Copper sulfate with zinc. You see the color? See those particles in the test tube? That's the evidence that yes, there was a reaction. Those are like copper, pieces of copper coming out, and lead is going into the solution. So we see these red color particles, that is copper, is coming out. So for test tube C, there is a reaction. Okay, test tube C, there is a reaction. Your metal ion was copper. The metal that was added was zinc, and there is a reaction. Zinc was added to lead. Zinc is added to lead nitrate. So D is lead nitrate. Zinc reacted with the lead nitrate. Zinc is going in and the lead is coming out. See the particles? The particles are on the wall. Just bring it closer to the camera for you to see it. The zinc reacted with lead nitrate as well. What does it mean? It means zinc is more reactive than lead. Zinc can give electrons to lead. Basically, this is like oxidation reduction type reaction. Zinc is being oxidized, lead is being reduced. E. What do we have for E? We have zinc and magnesium. Zinc and magnesium. Okay. I don't see any reaction, so no reaction. Zinc, magnesium, no reaction. Next one. Magnesium is, with F is magnesium with zinc. If zinc doesn't have reaction with magnesium, then magnesium must have reaction with the zinc when it's like the zinc is in the solution or the magnesium. Zinc in the solution. So metal ion is zinc and the metal is magnesium, and that is a yes reaction. Okay, there's reaction here. You see the particles coming out and the magnesium is going into solution. So for test tube F, there is a reaction. Okay? For test tube F, there is a reaction. When you have magnesium in zinc, magnesium in the zinc chloride, there is a reaction. Magnesium with sodium chloride, clear solution, nothing happened, no particle came out, no reaction. So you have no reaction here. For magnesium with sodium chloride, G, test tube G, no reaction. Test tube G, no reaction. Test tube H, magnesium with sodium chloride, no reaction either. See, it's clear solution, no particles came out, so no reaction. Letter H, there is no reaction. Okay, that was part 1 of the experiment. And for double displacement reaction, we have a table. In double displacement reaction or method-cis reaction, what is happening is like you have 2 solutions, the reaction takes place in aqueous solution. You have 2 solutions that they are aqueous solution, you are mixing together, and if you see evidence for reaction, you say reaction takes place, the reaction is happening, and if there is no evidence for reaction, there would be no reaction. What is evidence for reaction? If solid forms, a precipitate forms, then there is a evidence for reaction. If gas forms, that's evidence for reaction. If a liquid forms, that's evidence for reaction. If color changes, you see an obvious color change, then you have evidence for reaction. So basically, in this case, for this experiment, when we are going to take our test tube A or test tube 1. These are 1 to 12, okay? We have 12 test tubes. In test tube 1, we are going to add solution of barium chloride and solution of sodium sulfate. These 2 are in solution form because both of them are soluble. If they go through method-cis reaction, then there would be exchange in partner. Is going to be barium going with sulfate. The cation from the first one goes with anion with the second one. So it's going to be barium sulfate and sodium chloride. So it's going to form barium sulfate with sodium chloride. Now, if either barium sulfate or sodium chloride is insoluble in aqueous in water, you are going to see formation of precipitate in the aqueous solution. So if one of the product forms a precipitate, then you know that is not, that's the evidence for reaction. You know one of your product is not soluble. You can actually predict based on solubility chart if the precipitate is going to form or not. And you can identify what is the precipitate that is forming. Because when you look at the sulfates in this chart, and your professor is going to explain the chart, again, so sulfates are all soluble. On the next line, you have exceptions. So sulfates are soluble with exceptions to calcium sulfate, barium sulfate, silver sulfate. So this means barium sulfate is not soluble. So for test tube A, if you see a reaction, that reaction, the precipitate forms, is not the precipitate of NaCl, is not sodium chloride that is forming, because sodium chloride, if it forms, is soluble in water, but it's going to be the precipitate of the barium sulfate that is forming. So you are going to use your solubility chart. Whenever you have a precipitate, you are going to use your solubility chart to identify what was the precipitate, because this chart is saying what combinations is going to be soluble. Like if your compound contains group 1A, it would always be soluble. It doesn't matter if it's sodium chloride, if it's sodium bromide, or sodium acetate, or sodium sulfate. Whatever it is that has sodium is going to be soluble. If it has nitrate, it's going to be soluble. If it has acetate, it's going to be soluble, or ammonium ion is going to be soluble, with no exceptions. And everything else, there are some exceptions that you have to look at the chart and identify your precipitate. What is the precipitate? If you mix 2 clear solutions, you end up with clear solution. That means no reaction happens, no precipitate happens, because there was no benefit for that reaction, and your product is soluble in water. Okay, I'm going to start with the test tube. I'm going to label the test tube 1 to 12. And I'm not writing these formulas on the test tubes, what they are, because I have the table to follow. I know for test tube 1, I'm going to add barium chloride and sodium sulfate. So I'm going to take my test tube 1 and add the barium chloride and sodium sulfate. Okay, test tube 1, barium chloride, sodium sulfate. They have it all in one place, so I'm going to be looking for them to find it. But so I'm adding 5 drops of barium chloride, and then I add sodium sulfate. Sodium sulfate. This is for my test tube 1. Barium chloride, I'm adding sodium sulfate. Adding 3 drops of sodium sulfate. Okay. The product is milky. That means there was one product that was not soluble in water. If everything is soluble, we would see clear solution just like water. So if it's precipitate forming, we identify the precipitate using the solubility table. But since I already looked up this one, is the barium sulfate. So that's our test tube 1. Test tube 2, we have silver nitrate and sodium chloride. Silver nitrate, all nitrates are soluble. So you see the silver nitrate is a clear solution. Sodium chloride also is a clear solution. When I'm adding the two, a precipitate forms. That precipitate is not sodium nitrate because we know any compound that contains sodium is soluble. Any compound contains nitrate is soluble. So it's not sodium nitrate. It's going to be the silver chloride because they switch partner. Sodium chloride, silver nitrate. Now sodium goes with nitrate and silver goes with chloride. So this is the silver chloride. So you identify your precipitate based on solubility chart. Test tube 3. Test tube 3, we have lead nitrate and potassium iodide. Lead nitrate, going to add a few drops of lead nitrate and add lead nitrate, clear solution again. Potassium iodide, Ki, clear solution. And then it's forming a yellow color precipitate. So you record your observation when you are mixing the solution of lead nitrate with potassium iodide. What happens when you add the two together? Is there any evidence for reaction? Yes, it's color change and it's cloudy, so definitely there is a reaction there. For next test tube 4. Test tube 4, we have barium chloride and sodium carbonate. Barium chloride, have sodium carbonate, clear solution. That's not good if I don't have barium chloride. I need the barium chloride here. Okay, barium chloride comes. And barium chloride, we used it earlier. We got barium carbonate. Okay. So test tube 4 also precipitate. So we have a precipitate. And that should be barium carbonate because we mix the barium chloride with sodium carbonate. When the switching partner, sodium would go to chloride and barium would go with carbonate. Test tube 5. Test tube 5, sodium hydroxide and ammonium chloride. So in test tube 5, sodium hydroxide clear solution, sodium hydroxide being added, that's sodium hydroxide. And then I have another clear solution of ammonium chloride. Anything that has ammonium is soluble, of course. I mix it together and I get clear solution. What does it mean? It means that this mixture did not form any precipitate. There is no evidence for reaction. So for 5, there would be no reaction. So 5, no reaction. 6. Test tube 6. Lead nitrate with sodium sulfate. Lead nitrate. Is a clear solution. Then we add sodium sulfate. Here. I think sodium sulfate is the one that couldn't squeeze it. Sodium sulfate with lead nitrate. Gonna add few drops. Test tube number 6. White precipitate. That's going to be lead sulfate. Remember, partners are changing. Sodium was with sulfate, lead was with nitrate. Now lead goes with sulfate, lead sulfate. Test tube 7. What do we have for test tube 7? Sodium sulfide and hydrochloric acid. Sodium sulfide and hydrochloric acid. So I'm looking for HCl. Is this here or not? HCl. Hydrochloric acid and sodium sulfide. Na2S. Test tube 7. No reaction either. So mark no reaction for 7. Test tube 8. We have copper sulfate and sodium hydroxide. sodium hydroxide and copper sulfate. The blue color stays, but the blue color that we have for copper sulfate is clear blue color, but this one is cloudy, so there is a reaction. Okay. Blue color precipitate that changed the solution to cloudy mixture of solid and liquid. So test tube 8, yes, reaction, and you have blue color precipitate. 9. Test tube 9, we have lead nitrate and potassium chromate. We have lead nitrate. See, it's clear, colorless solution of lead nitrate. Potassium chromate is clear, but yellow color solution. There is no precipitate in there. There is no solid. Both of them are aqueous solution. One had just happened to be yellow color, but it's clear. When you mix it, you get this yellow color precipitate. So for test tube 9, evidence is yellow color precipitate that it forms. There is a reaction, and the precipitate that forms, the insoluble compound that forms, if you do like double displacement, see, you are going to take the lead with chromate. So lead goes with chromate, potassium goes with nitrate. Potassium nitrate stays in the solution. Lead chromate is going to be the solid that is forming. Test tube 10, iron nitrate and sodium hydroxide. Okay. Iron nitrate is a yellow color but clear solution. Okay. Clear solution. And we want to add sodium hydroxide. We have it somewhere. Sodium hydroxide. Okay. It turned cloudy. So orange color precipitate form is an orange cloudy solution mixture. So orange precipitate form. So for test tube 10, you do have a chemical reaction also because of precipitate form and it's cloudy. 11, silver nitrate and sodium hydroxide. Okay. 11, we have silver nitrate. Adding few drops of silver nitrate. And we add sodium hydroxide, silver nitrate with sodium hydroxide. See, all different colors of precipitate. It's like a brownish color precipitate we have. Silver hydroxide. This precipitate is called silver hydroxide. Okay. Next, or last one, 12, sodium chloride and calcium nitrate. Sodium chloride, obviously, clear color solution, and calcium nitrate. Calcium nitrate. Sodium chloride with calcium nitrate. Okay, if you switch these, it gives you calcium chloride and sodium nitrate. Sodium nitrate is soluble. Calcium chloride also is soluble based on the solubility table. Because all chlorides are soluble, it's expressed in the solubility table. All chlorides are soluble with exceptions to silver, lead, and mercury. So calcium chloride is soluble and sodium nitrate is soluble. That's why you get clear solution, no reaction. So for test tube number 12, there is no precipitate, no reaction for test tube number 12. So the test tube number 12, there is no reaction. No reaction for 12. So we're done with double displacement reaction, single displacement reaction. You're not done with your experiment yet, because in this part, number 5 here, is asking you to write the chemical reaction. You just have to add the two reactants from test tube 1, compound A plus B, switch it, and make sure that you have the product in a way that they have switched or exchanged partners. The metal cation from the first one goes with the anion from second one, and then cation from second one goes with the anion with the first one. You write your chemical reactions. And then any reaction that doesn't have evidence for reaction, you can write no reaction, or you could write it down and then say no reaction. So you're just going to follow the procedure. For the part 6, you're going to write ionic equation. When you're writing ionic equation, anything that breaks down to ions, that means the compounds that are not soluble, they are going to stay in the solid form. But if they are soluble, they can break down to the ions. Let's say when you mix the first one, for the first table, when you mix the test tube 1, you mix the barium chloride and sodium sulfate. Barium sulfate forms the solid and is going to stay at BaSO4, and you don't separate them. It doesn't change to ions. But the second compound, which is the sodium chloride, it changes to ions of sodium ion and chloride ion. So when you're writing net ionic equation for question 6 or part 6 of the data sheet, you only change the compounds that are aqueous into ions. If they are solid, it stays. If it's liquid, it stays. If it's gas, it stays. But for this example, you either have aqueous or solid. You don't have the gas liquid as example. So it makes it more straightforward for precipitation reactions. So if it's solid compound, it stays together. Do not break it down. And then if it's aqueous, you change to the ions. For part 7, when you have your ionic equation, you are going to cross down the spectator ions. Spectator ions, those are the ions that they appear exactly the same on both sides of the equation. So if you have an Na plus on the reactant side, you have Na plus on the product side, that is called spectator ion. You are going to cross it. Then you end up with whatever is left as the net ionic equation. Net ionic equation is responsible for evidence for reaction. So for the example with the barium chloride and sodium sulfate, the product that is barium sulfate, you're going to end up with net ionic equation. If you do every step correctly, your net ionic equation is going to be Ba2 plus, which is the barium ion, plus the sulfate ion that gives or yields barium sulfate solid. So that would be your net ionic equation. So for any reaction or any test tube that you did have a reaction, you should have a net ionic equation. If you have no reaction, like test tube 12, you had no reaction, everything is going to cancel from both sides of the equation. The spectator ions, when they cancel, you end up with 0 net ionic equation. So that means there is no reaction also. It's a proof that there is no reaction. Okay, we are done with experiment 7. Hopefully you can record all your observation and complete the data sheet for experiment 7 and turn it in as an assignment to your professor if it's me or anyone else from Central Campus. Thank you.